Alright, sorry about that. I didn't like the way these notes are. So here we go. Horizontal shift. I have x minus h here. So if this said x minus 5, when I set this equal to 0, x minus 5 equals 0, I would add 5 to both sides. And I found that x actually equals a positive 5. So because the formula is x minus h, if h is positive, when it's positive, then it's going to look like it's negative here because it would be x minus h. The graph is actually going to move left. Make that change, please. If h is negative, so if I had, say, x minus a negative 2, we would see it as x plus 2. So then I take x plus 2, set that equal to 0. To solve for x, I would subtract 2 both sides. X equals a negative 2. So if h is negative, if h is less than 0, then the graph is going to move to the right. Again, the easiest way to understand this is that whatever bound up with the x, you set it equal to 0 and solve, and you'll be able to see where it goes. Another way is to remember that the horizontal shift goes in the opposite direction. My pen is giving me fits. Alright, let's continue. Growth or decay. If b is greater than 1, in other words, the base of the exponential, what's being raised to the exponent, it is growth. That would be like 2 to the x, that is growth. Matter of fact, that's a doubling function. It could also look something like this, so be careful. I could have 1/2 times 3 to the x. The b here is actually the 3. The 3 is bigger than 1, so it's a growth function. The 1/2 out here, hey, that's kind of where I started. That's my initial value, or my stretch, or my shrink. Alright, if 0 is less than b and b is less than 1, again, we want to talk about our absolute value of b being here. So in other words, if it is a decimal like 0.5 or a fraction like 1/4, then that is going to show decay. Okay, my growth functions are going to go up like this and come down and approach an asymptote. My decay functions are going to go down like this and approach some kind of asymptote down here. So here's my first example. Y equals 2 to the x. The parent function is what I'm looking at. That would be 2 to the x. Transformations, none. In general, I know that this is a basic growth function. It hasn't been shifted up or down. It's going to have an asymptote at y equals 0, and it's going to go up like that. So this is a growth function. My b is greater than 1. My asymptote is y equals 0, which is my default asymptote if I haven't been moved up or down. And this has not been moved up or down. I could put a plus 0 at the end. And let's get some points. Alright, to get some points, I'm going to go to my calculator, hit the table feature, clear it out. I'm going to put in the function 2 raised to the x, enter. I'm going to start at 0. I'm going to set by 1. You may or may not have to mess with that. And here we go. Alright, so here's some points. I have I'll write mine in a T-chart. I got -1 and 1/2 or 0.5. I've got 0 and 1. I've got 1 and 2. Two and 4 and 3 and 8. That's about all that's going to fit on there. 3 and 8. Well, let's arrow down here just a little bit and see what happens. See how big this is getting fast? That's an exponential growth power there. So it's going to go off your curve really fast. Alright, so we plot some of our points. I go -1 up 1/2. 0, 1, 1, 2, 2, 4, 3, 8, 1, 2, 3, 4, 3, 8. Now I'm going to try to draw a nice smooth curve through my points. Coming up off my asymptote down here. Nice smooth curve. If I'm drawing an exponential, I need to see my asymptote, so that you guys can make sure that you see what I did here. My asymptote here, it's a little big, is here at the y-intercept. And again, an asymptote is a line that approaches but never ever touches or crosses. So my asymptote's y equals 0. My domain, I go as far as I want to, back here to the left. I go up off the graph, I continue going up, I continue going right. So my domain is from -infinity to +infinity. By the way, this is the domain for all exponentials. My range is restricted by this asymptote. So my range, coming up from the bottom, first thing I see is this asymptote, which is y equals 0, and I continue on through the graph to +infinity. Can't touch infinity, so that's a soft parenthesis, and I can't touch an asymptote, so that's a soft parenthesis. X-intercept, am I ever going to cross the x-axis? No, because that is my asymptote. So I should have no or none for my x-intercept. For my y-intercept, there it is, 0, 1. So I can put that in. 0, 1 is my y-intercept. As I look at this function, is it increasing or decreasing? As I look at it from left to right, is it going up or down? Looking at it from left to right, clearly it's going up, so it is a increasing function. Last thing here, in behavior, as x approaches -infinity, in other words, I'm going left. So as I go left, the function's getting closer and closer and closer to my asymptote. And my asymptote in this case is 0. As x goes to the right towards +infinity, it's getting closer and closer to +infinity for my curve, or f of x. My end behavior for exponentials, one's always going to approach an asymptote, another one's going to approach one of the infinities, either positive or negative. Depends on the picture. Alright, let's try another one. Y equals 3 to the 1/2 of x raised to the x, or y equals 2 raised to the -x. Remember, the negative exponent flips the base over the fraction bar. So these two are equal equations. They mean the same thing. It's easier for me to see what I want to in this format here, because I see that my b is clearly a fraction. So this is going to be a decay function. So in general, this function should come down like this, approaching an asymptote as it comes down. So the parent function is y equals 1/2 raised to the x. I only have one transformation here. It's a vertical stretch. By 3. And that came from right here, a vertical stretch of 3. Some points on the graph. Again, I'm going to make a T-chart real quick. Okay, you can plug into your calculator and get your points. 3 times 1/2. You could put it in as 1 divided by 2 if you wanted to. Raised to the x. And I'm going to start here at -1. Enter, enter. Alright. So I've got point -1,6. I have 0, 3. 1 and 3/2. 3/2 is the same as 1.5. And I keep getting smaller and smaller fractions here. Okay. So I see 2 and 0.75. I'll go ahead and write that one down. And we'll go ahead and plot our points. -1,6, so -1 up 1, 2, 3, 4, 5, 6. 0, 3. 1, 1.5. 2 and 0.75. 3 would be up half as far. Next is going to be up half as far. And so what's happening here is getting smaller and smaller and smaller. I'm approaching that asymptote we discussed, but I can't actually touch it. It's really hard to graph past this point. So now I want to draw a nice smooth curve. Going through my points. And approaching my asymptote. It's going to keep going. It's going to keep getting closer and closer to my asymptote. And as I go back the other way, it's going to go up off my graph. So now I can clearly see this is a decay function. My asymptote hasn't changed. So this is y equals 0 because it was not shifted up or down. I could put a +0 at the end of both of these. It has not moved up or down. My domain for all exponential functions, -infinity to +infinity. My range is restricted, coming up from the bottom. First thing I see is my asymptote. That is a minimum from 0 to +infinity. I can't touch infinities and I can't touch asymptotes. Those have to be parentheses. X-intercept. Well, the x-axis is my asymptote, so I cannot have any x-intercept. So I can put NA or none there. Y-intercept. I hit it right here at 0, 3. I see it right here. So I'm going to tell you that my y-intercept is 0, 3. Increasing or decreasing? Well, as I look at the function from left to right, it is clearly falling, so that is a decreasing function. My end behavior as x approaches -infinity. In other words, I'm going left. So as I go left, my curve, my graph is going up to +infinity. As x goes to +infinity, in other words, I'm going right. As I go to the right, I get closer and closer and closer to my dotted line, which is an asymptote. So I get closer and closer to my asymptote, which is y equals 0. So the curve gets closer and closer to 0, but it's never ever going to touch it. So again, the end behavior for exponential functions, one's going to approach one of the infinities. The other one will approach the asymptote. Again, it depends on the picture.